Theory and stochastic process. Previous lecture, we have learned about what is the meaning of variable length coding and what are the different techniques under it. Huffman coding and Shanon Fano coding are the two prominent techniques at the learning level. Okay, at the advanced levels, there can be many other techniques. However, we are going to talk about the basic ones only. In Huffman coding, we have seen how the coding has been done. The symbols are arranged in descending order. At every level, we add last two probabilities. This process is continued till only two probabilities are left. And then the code assignment starts. Upper probability is given 0 or 1, with lower probability is given 1 or 0. It depends. Either is. But only one thing in the coding is we have to follow same strategy. If you are allocating 0 to the top and 1 to the bottom, continue, or 1 to the top and 0 to the bottom, continue. You should not deviate in between. Now coming to your Shanon Fano, it is simply more simpler than your Huffman coding. Okay, here also almost same steps. It is going to consisting of same step as in the case of Huffman coding. But the only difference is it is quite easier. So directly, as the process is known, directly go with the example itself. And what is the key concept behind variable length coding that we just mentioned? Shanon Fano coding is again a variable length coding technique. It is again a variable length coding. What is variable length coding meaning? In variable length coding, the code words assigned are not of fixed length. Based on the symbol probabilities, the code length varies. Strategy: more probable symbols, less number of bits. What it means? A symbol having more probability is given less number of bits. A symbol having less probability is given more number of bits. So let us just see this example. What is asked? Construct Shanon Fano. So as in the previous case, the initial process is same. Write down the symbols. Okay. Ith symbols are case symbols. Mention their probabilities. Okay. P of x. So what are the symbols given here? Q1, 5 symbols only. Q2, Q3, Q4, Q5. Probabilities given are 0.4, 0.3, 0.1, 5, 0.1, and 0.05. Is it okay? Only 5 symbols. Hope understood. What is the meaning of a symbol? Symbol means whatever you are using to convey information. Suppose I am using English language. My symbols are A, B, C, D, etc., etc. So on. So, okay. After this stage 1 or step 1, what do you have to do? Arrange the symbols. Okay. In the descending order of probability we won't consider, but the difference between the earlier case and this case, you can just proceed in this manner. Okay, 0.4, 0.3, 0.15, 0.1, 0.05. Now, in this Shanon Fano coding, what is required is five probabilities are there, no? So divide this complete probabilities into approximately, if possible, either equal intervals. If not possible, approximately equal intervals. This is very, very key point. In Shanon Fano code, after arranging symbols in descending order, group the probabilities into two equal intervals. See, this is 0.4, this is 0.6. Somebody may say, sir, I will draw a line here. If you draw a line here, it is 0.7, 0.3. No, no. The intervals must be approximately equal. 0.4, 0.6. Difference is 2. If you draw a line, 0.7, 0.3 difference is more. So they must be divided into two approximately equal intervals. Understood? This is 0.4. If you add all these probabilities, how much value? 0.6. Case 1. If I draw a line, 0.7, 0.3. No, they are not equal approximately. Done. So upper one is 0, allocate lower one. Is there any possibility of dividing this interval? No, as only one probability is there, no further division possible. But see here, there are 4 values. I can divide them into equal intervals. Equal. This is 0.3, 0.15, 0.1, 0.05. This is 0.2. So we again divide here into equal intervals. So this is 0.4, 0.3, 1, 0, 1, 1. Is it clear? These 4 intervals are divided into 2 equal intervals. This is 0.3. Add all these 3. If these 3 are added again, 0.3. Okay, right. Any further division possible here? No, close. But see this. 3 intervals. I can divide them into equal. 0.15, 0.1, 0.05. Again 0.15. Again 0, 1. Again divide. See here. Close. I can again divide here. So 0. So at every level, we can divide the intervals into approximately equal. Coding is completed. We have to come back. We have to come back, assign the values. How we assign 6.4 directly. So 0, 0.3, 10, 0.15, 110, 0.1, 110, and not 5 is 1. Right? We have observed in this example, the probabilities were already in the descending order. 0.4, 0.3, 0.15, 0.1, and 0.05. No need for you to again them especially in the descending order. But sometimes it is need not be necessary to arrange them. So let us go with one more example. Okay, to better. Finally, don't forget you have write a table consisting of symbols, their probabilities, and allocated code words. What are code words? 0, 1, 0, 1, 1, 0, 1, and 1, 1, 1. Okay. So let us take one more case. One more example we do. Yeah. So this consisting of some 7 symbols. The probabilities of these symbols are 0.15. This is 0.1. Right? Probabilities. Are they? Okay. 0.35. 1, 2, 3, 4, 5. 0.3. 0.45. Check once. Let us verify. Because we have condition, don't forget. Sum of all probabilities must be equal to 1. 0.65. 0.8. This is 0.5. 0.65. 0.8. 0.9. Right, done. Okay. Now let us go with the Shanon Fano. Probabilities are given. Proceed. First of all, what is required? Xi. Okay. P of Xi. Start. X1. How many? X2. Sorry, not X1. Q1. Q2. Not Xi and so on, so on, so on. Symbols are given now Q1 to Q7. They are not X1 to X2. Q1, Q2, Q3, Q4, Q5, Q6, Q7. Probabilities. 0.35, 0.15, again 0.15, again 0.15. This is 0.1. This is 0.05. This is point. Okay. Then stage one. What is Shanon Fano's first step? In Shanon Fano, we have to divide the given probabilities into two equal intervals. See this. 0.35, 0.15 is 0.5. Now, if we add all these things, again 0.15. So divide here. This is 0. Remember now, upper group 0, lower group 1, 1. Close. And see here two values. So again you can divide into two, right? So upper one is 0, lower one is 1. You can call step 2. And in this case, 0.15, 0.15, 0.3. So approximately 0.3 is sum of these two, 0.2 sum of these two. So this is 0, 0, 1, 1, 1. Again, two values, divide them into equal intervals. Upper one is 0, lower one is 1. Because 0.15, 0.15 are equal, no? So the step is remembered. At every level, divide each group into two approximately equal groups. Let me just mention here. Every group into two subgroups. They must be approximately equal. This is to be remembered. Approximately only, no issue. See this 0.1. If I add these two, 0.95, 0.05 plus 0.05 is again 0.1. So divide. Upper one is 0, lower one is 1, 1. This is closed. This is closed. No division possible. No division possible. In this case, two probabilities are there. 0.05, 0.1. Again divide. Upper one is 0, lower one is 1. Any further division is possible? Verify? No. So 0.35 is 0, 0, right? Let me just mention this case. Q1, 0, 0. Okay. Q2, 0, 1. Directly Q3, 1, 0, 0. Table we have to mention. Q4, 1, 0, 1. Q5, 1, 1, 0. Q5 is 1, 1, 0. Wait. This should be 1, 1, 0. Q6, 1, 1, 0. Q7 is 1, 1, right? This is 1, 1, 0. This is about the Shanon Fano coding when the message symbols are symbol probabilities are given. The probabilities were not mentioned in subsequently proceed in the another manner. As we have done in the case of F1 coding, here also we have to get the message symbols in probabilities and then correspondingly perform the Shanon Fano coding. Okay. Keep learning. Thank you.